Hello all and welcome. So in this video we are going to see higher order differential equation with variable coefficients. Any equation of the form an into x raised to n d raised to ny upon dx raised to n plus a n minus 1 x raised to n minus 1 d raised to n minus 1 into y upon dx the whole raised to n minus 1 plus and so on. A2 x square d square y by dx square plus a1 x dy by dx plus a0 into y equal to x. So any equation, if it is in this form, then this equation is called as variable coefficients. Why it is called as variable coefficients? So in our previous videos we saw that if any equation is in this form, then this equation is called as higher order differential equation with constant coefficients. Why it is called as constant coefficients? Because here an minus 1, a2, a1, a0 all are constant. So the coefficients of each derivative term is constant. But in this case we have constant, but we also have x raised to n minus 1 x square into x. So along with the constant we have x term in each of the derivative. So that's why this equation is called as higher order differential equation with variable coefficients. So whenever we have such type of equation, basically this equation is also known as Cauchy's equations. So there are two types of higher order differential equation with variable coefficient. One is Cauchy's equation and other is Legendre's equation. Legendre's equation we will see in our next video. So this is our Cauchy's equation. So whenever our given equation is in the form of Cauchy's equation, we put z equal to log of x. This is the basic substitution for any type of higher order differential equation with variable coefficient, provided it is a Cauchy's equation. In Cauchy's equation we have x raised to n minus 1 x square x terms along with the derivative, and also we substitute x into d by dx equal to capital D. In this type of problem with constant coefficients, we used to substitute d by dx equal to d. Now we are going to substitute x into d by dx equal to d. So in this case x square d square by dx square will be nothing but d into d minus 1. Similarly, x cube into d cube upon dx cube will be d into d minus 1 into d minus 2. So this is the basic change between the constant coefficient and variable coefficient. In variable coefficient, if it is a Cauchy's equation, we substitute z equal to log of x and we substitute x d by dx equal to d. So when it is x square into d square by dx square, we substitute d into d minus 1, and in this case d is also represented as d by dz. As we used to represent here, d in this case will be represented as d by dz. This will be more clear when we see the problem on this type. So the question is x cube into d cube y by dx cube plus x square d square y by dx square minus 2y equal to x square plus 1 upon x cube. So if you see in this equation we have x cube, x square in front of derivative. This is a Cauchy's equation. So in Cauchy's equation we put z equal to log of x. Then our x will become e raised to z. We also substitute x into d by dx equal to d. Then we substitute x square into d square by dx square equal to d into d minus 1, and x cube into d cube by dx cube we substitute it as d into d minus 1 into d minus 2, where d is nothing but d by dz. So this is the basic substitution for Cauchy's equation.